Welcome to the video explanation of persistence of vision on the ADC shield, the code written for it. Basically, we have our lookup table with bytes 0 to 9 in flash memory, and then this is the number that we want to display. We have our setup information here, in which we grab the address information of the 2-digit number we want to display, 47, and then using the address information, we load the contents into the util register using loads program memory, LPM right here. I guess moving to the top, we want to evaluate we want to split the 2-digit number into the ones and tens digit, or the tens and units digit, right? So we just clear the tens register, and then we subtract 9 from it constantly until we run through enough iterations such that the number becomes negative, right? And the number of times that you can subtract 10 before it becomes negative becomes the number in this tens register, right? And then after you add 10 again, and then you get your units digit, right? We added 10 here, and then we can subtract a 10. Next, what you do is that we store this back to SRAM using these commands here. So res was where we had our 2 bytes reserved initially at the start of the code, and we load our tens information here, and then the byte right next to that we load our units information. Here, these two commands are just to kind of create our index pointer so that we could point to the number that we need for our digit in the array. Here we've gotten the address information of our lookup table, right? And what we do is that we load the byte in SRAM back to the util register, and then we use these commands to function as an index so that we can point to the corresponding number, the number that we need for either the tens or ones digit. Here we're just loading the byte to register that we're using to hold the information. We then shift out the information, right? You'll notice here that we're determining using determine display or det display whether we want to show the tens digit or the ones digit. Obviously, we're going for the ones digit first. However, so if we go over here, we just compare the lower end of the Z register to the tens digit, to the information in the tens register or the tens digit, and if they match, then go to the show tens command, which I have over here. Show the tens command. So we just clear the the transistor that would allow the 1 7-second display to turn on, and if it's not equal, then we show the ones, right? And then we have a delay in between just to prevent ghosting. So that's basically my video explanation.